I am putting in another order for some CDs, so I've updated the album artwork, which I think I like more than the previous run. And I added this little bit. Be a star. Again.
Have you ever heard somebody say that we're all stardust? Or, as Carl Sagan put it, we're all star stuff. Well, it's not just a cool thing to say, it's true.
If this was not the case, then a lot of the technologies in your phone wouldn't exist. And I am going to explain to you why. See, the vast majority of elements that make up this planet, this solar system, all the hard stuff in this dirty lab, they're formed in the nuclear furnaces of stars, like our sun. Our sun is a star, a giant ball of gas of hydrogen and helium that gets so hot and energetic that they crash into each other and form heavier elements, the majority of the elements that make up the universe. A young star has tons of hydrogen and helium to burn. Later on, it needs to start to fuse heavier and heavier elements in order to keep the nuclear fusion process going. That's when it gets into the silicon burning phase, burning silicon and sulfur and calcium and titanium until eventually it gets to iron, and then something happens. This is a plot of the nuclear binding energy versus the atomic number. The nuclear binding energy is the amount of energy it takes to split an atom up or put an atom together, like a nuclear fusion. And like nuclear fusion, you can burn through heavier and heavier elements until you get to iron. See that at the very top, right next to nickel? After that, the slope is negative. It takes more energy to form an atom than you get out of it, and that's not sustainable. At this point, what happens to the star depends on how big it is, how massive it is. If it's a less massive star, like the sun, it essentially runs out of gas. Not entirely, but it can't support nuclear fusion anymore, so it gets cold and turns into this cold, heavy element thing we call a brown dwarf, which is kind of like the planet Jupiter, but just more massive than Jupiter. But for more massive stars, stars that are about 10 times more massive than the sun, something else happens. You see, they have these enormous gravitational potentials trying to crush the star down. The only thing that's keeping that from happening is nuclear fusion, pushing it out. So as soon as nuclear fusion stops, blammo! Once nuclear fusion stops, gravity wins, and all of the mass of the star comes crushing down on itself, causing a supernova, a giant explosion in space releasing a lot of energy. This supernova, with the help of gravity, is able to produce energies that far exceed that of nuclear fusion. And what does that mean? It means we're able to accelerate atoms and crash them together to produce heavier elements, heavier than iron. Remember this nuclear binding energy curve? Everything after iron was created in a massive supernova of an ancient star, including all this highly radioactive stuff, like uranium. We use this in fission plants and bombs. Okay. Let's return to the original claim that I made at the beginning of the story, that the technologies in your phone wouldn't exist if we weren't Stardust. I mean, you wouldn't exist either, but people care a lot about their phones, and it just seem like edgy. Does this look familiar? Yep, it's the periodic table of elements, and iron, with an atomic number of 26, that's 26 protons in the nucleus, as well as some isotopes of nickel, are some of the most tightly bound atoms that could be formed via nuclear fusion. Everything with an atomic number of 26 and higher were likely produced in a catastrophic explosion of a dying ancient star. That means all of the copper that are used in this printed circuit boards of your phone, it likely has immersion gold plating on the contacts, maybe even leaded solder, and a lot of other heavy elements that are necessary for the technologies of your phone were created in a dying star, as well as a lot of the processes that we know are essential for life on this planet. So, when you hear somebody say, we're all stardust, it's not just a cute thing to say, it's true. An ancient star at one point died, but was reborn into our sun, all of our planets, and us. It's pretty cool. Maybe that's something we could be thankful for this Thanksgiving. Or pie.